Welcome everyone to this week's IPLD Sync meeting. It's October the 19th, 2020, and as every week we go over the stuff that we've worked on the past week and then discuss any agenda items, and today we even have an agenda item. And yeah, though we still start with the round of updates. So I start with myself, and actually this week I had plenty of stuff in the IPLD world to do, which is great. So on the documentation side, I've made the 2 pull requests into explorations report with a small script, which does everything automatically. I had to patch it a bit, but now it's quite nice. And I think the output reads quite good as Markdown. So I've done those. And on the Rust side of things, so currently I still wait with the Rust multi-hash release until I'm sure that it works well for the libp2p forks. I've done a pull request on libp2p, and I hope that they would reply quickly, but they haven't. So it's been 6 days or so. So I've pinged them again on IRC and just see if there's anything I could do to get this reviewed. But as this also blocks the Rust CID release, what I'm gonna do is that this week I will just, so there are a few changes that I think they would need. I will just make sure that those just get merged with the Rust multi-hash. And if I then, by the end of the week or so, not hear back from them, I will just do a release, then do a Rust CID release. And then if there's anything that they still need, there might be just another breaking change release. So I don't expect it, but in case they do, I will just do another release, and yeah, we'll figure this out. But I don't want to be blocked on libp2p review. On what else I did, so there is the simple DAG stuff that has coming up in this meeting quite a bit. And I looked into it again because Eric was actually mentioning how is this different from DAG CBOR? And then I looked into it and decided to make a pull request to show that it's actually quite similar. It's linked. So yeah, it's basically what it shows is that if you really only implement a subset of CBOR, which we need for DAG CBOR, if you only implement those things, an encoder and a decoder is actually quite easy to do with not that much code. And then on Friday we had a long discussion on IRC about IPLD and strings. The point is that I think that the IPLD data mode strings should be valid UTF-8, and Eric thinks that the IPLD strings should be just 8-bit byte sequences. And he has published a document, and I've published a reply to it. And yeah, I think this will be a discussion that will be ongoing and that, we will have for quite a while. We'll see how this turns out. Okay, that's all I did in the IPLD world. And next on my list is Danielle.
Cool. So one of the things I did last week is get a new microphone. So hopefully my audio is better now. But besides that, it was a bit of a short week for me because I was giving a talk today at a Go conference called Go Lab. So I had to record a talk for it because they don't do live talks. And you don't learn how difficult it is to do like a full hour edited talk until you try it for the first time. So I spent a lot of hours on that, but mostly the weekend, but also a little bit on Monday. And then obviously the live Q&A today. Besides that, we did a call with Rod and a couple of other people to finish up the HAMT spec changes that we had been talking about. So that went well. Thanks, Rod. So I tried to switch my ADL repo to that new schema. And I spent most of today on that, and I was stuck for a while. And initially, I thought it was my fault because when something doesn't work, you kind of assume that it's your own fault. But after some digging, I kind of realized that the spec is inconsistent because the new hash map node type, sometimes it's represented as a map and sometimes as a tuple or list. So the schema doesn't really work. And then Eric's code generator, it could give a nice error, but right now it just spits out invalid Go code. So that's what was confusing me for a while. So I think we can talk about that later. rather how to fix it. So otherwise, I've been adding more tests and fixing to-dos in the ADL repo, but nothing that I've pushed so far yet. And I also filed some of the simpler Go IPLD prime issues, or rather design changes, that we had been discussing with Eric. The more difficult ones, I'm leaving them in the draft notes for now because it's not anything that, those are not anything that we could fix anytime soon. So, and that's it for this week.
Thanks. Next is Rod.
Okay. So it was mostly a Go week last week. I took on board some of that Go maintenance that we talked about last week. And the main thing I focused on was Go CID, which is now fully updated and happy. And I increased the test coverage by 30% while I was at it, because the repo had a coverage rule for things to be merged, and it just slipped below that, and so none of the pull requests could get merged. And so instead of trying to find someone with administrative access, I decided to just increase the test coverage because that's a good thing anyway. So I actually managed to test some areas that just were not, like, there were whole masses of code that just were not touched. So it was good to touch them and to validate what they're doing, what they're intended for. I think Go CID might need a release, but I don't know what the process was there. So I might need to figure that out and figure out whether I can do a release. I also think it might be good to get Daniel access to the IPFS Go team, since some of these pieces are over in the IPFS repo, and Go libraries are kind of hard to move. More tinkering with IPLD Prime and a DAG PB thing. Touching lots of things inside IPLD Prime from the inside, and hitting some interesting places. But mostly that's going surprisingly well. I'm not having the pain that I'm not having much of the pain that I thought I might do in trying to make it work, at least. So in my initial test runs are showing that the thing's working as it's supposed to be. So looking good. We did the HAMP stuff, which we need to revisit probably today. We can probably knock that off in this meeting at the end. And then just administrative stuff, including the peer review stuff, which that's just sapping work. Aside from that, just mostly little bits and pieces. So not a big week.
Next one is Michael.
I am. A lot of what I dealt with was the review stuff as well. Probably have another round of that next week. This week I actually have to write a talk for FileCoin Liftoff, so that's going to be fun. So main kind of code stuff that I did, though, is that I did get back to that DKV, that little key value store, and just started adding coverage and tweaking it. I'm really liking it. I think I'm going to write a little blog post, probably on the IPFS blog, about kind of like how would you write a database on top of IPFS, and then just use the DKV library as like an example, basically. That seems like a good idea. But that's the main stuff that I have that I can think of right now. Interested though in Rod's talk later about the HAMP changes. So.
Next is Peter.
Right. So last week I assisted the people who launched FileCoin. So we did launch FileCoin. It was very quiet, actually suspiciously quiet. We probably will see some stuff this week. Fingers crossed we don't see anything, but one never knows. So one thing that is kind of IPLD related and is somewhat interesting to this team, because a lot of you guys worked on this, was, as you might know, we had a few hiccups with how we actually transferred the data from the data that we assembled for FileCoin Discovered, how we transferred it from AWS to actual hard drives. There were a number of mistakes made along the way. So just literally yesterday, we wrapped up a project to ship a very small, very foolproof program that is able to take a random drive and basically say whether it is good or not good for the purposes to which we, whether it was assembled good enough for the purposes that we are trying to use it for when we actually start sending deals and stuff like that. So the amount of things that we had to figure out how to do is, because of the hostile place where this thing is run, it doesn't really have a good like backend service or anything like that. So step number one was basically just take the entire Dynamo table of comp piece, like the entire thing, cut it down to 16 bytes of hash for each CID instead of the full 32, and just bundle this thing entirely into the binary, which is only like 140 megabytes, so it's not that bad. So basically, whoever runs the program has the entire data set of what is actually a computer to expect and what is the size of the file to expect, and which data sets they're part of. All of this is like part of the thing. Also, we have an actual compy calculator that is not based on the Rust FFI stuff, but it's entirely implemented in Go. It is only 3 times faster than what we use in Filecoin right now. I haven't spoken to the crypto lab people yet because it is implemented efficiently. It's actually supposed to be 10 to 15 times faster when everything works together, and we basically can channel the different layers in parallel so that it can utilize a decent CPU with, with SHA instructions. So it can run things at about 500 megabytes per second to 1 gigabyte per second in constant memory. So right now, the program actually takes about 50 megabytes of memory to process an entire car file. It just takes slower than I would like it to do. And once that is ready, hopefully this week I'll be able to clean this up. We will try to push it into Lotus as well. And yeah, that pretty much is what took like 2-3 days of work, but it's finally out, and now we'll see if multiple people running this will be able to find extra bugs or not in the implementation of OFF-R32. And yeah, I think that's all I have. Who's next?
Next is Eric.
So I don't have a ton to report this week. I had a lot of non-IPLD things to deal with in life this week. But I guess, since you brought it up already, Volker, strings. I thought a lot about strings. Strings are one of those things that we really need to specify in some way or another, unfortunately, frustratingly. Because despite strings being this super common concept, common doesn't mean well specified. So if we're going to try to grow this whole ecosystem full of like many different implementations of libraries, many different codecs, many different applications built on top of them, interfacing with many other different kinds of applications, interfacing with kernels, interfacing with file systems, interfacing with everything under the sun, we really have to specify what we actually mean, even by really basic stuff like strings that we would like to take for granted. So I tried to do that. I have a big old document. It's a GIST form. It's one of those things that I've written in the sort of exploration report style format. So it takes a position and it runs with it. And it's written in a single author way as if that this was the truth. So it's split into several sections. It's way longer than anyone probably wants to read. I'm sorry. It talks about where strings appear. It proposes a definition, which, like Volker spoiled already, the definition that I would advocate for is strings should, caps lock, RFC, whatever terminology, should be UTF-8. However, complete IPLD libraries must, caps lock, support the full range of 8-bit byte sequences. The details of that are covered. It goes a lot into the design rationale. I've got 6 distinct ones separated out there, or is it 7? And then there's a whole chapter full of alternatives And all of these are labeled as rejected, but I want to restate that this is because this is written in the exploration report style. So it took a position and it's running with it. Some of these things are more thoroughly rejected than others, but they have between 2 and 8 reasons why I consider them not such a good idea. But some of these, I don't know, maybe they're salvageable. If somebody wants to take this all in a different direction, what I would suggest is read this, and if you want to pluck one of these things out, pick one of them and try to run with all of the concrete implications of what would need to change in order to make it happen. So for example, one of the things that's rejected is maps with mixed key kinds. Because if we supported maps with mixed key kinds entirely, then a whole bunch of the debate about how strings need to be specified would actually change. It would loosen some constraints, it would add some new ones. And it's very non-local, which of those things it affects. So if somebody wants to try to take that definition and run with it, that would be really cool. But good luck, because just saying, no, I don't want it to be rejected will not get you very far. You actually have to work through the implications of all these things. When I've tried, I've ended up failing to be able to work through the implications of a lot of these, but maybe some of them are possible. I just don't have enough headspace, right? One of the other alternatives that's in here that I've marked as rejected, but maybe it shouldn't be, maybe you could do this, is we could change the data model to have multiple map kinds. We could have map with string keys as a distinct kind from map with byte keys, and another distinct kind for map with int keys. That would be an option. It would be radically different than what we've defined so far, and would require updating a lot of specs and rethinking a lot of things about how codecs have bijections on the specs, and so on. But it might be coherently possible. Anyway, so this talk covers a lot of those things.
So there was a crazy discussion that I had with Volker today, actually. And this is like a good time to kind of put this on your radar. We're talking about the map key thing and within the context of strings. And we're talking about kind of like if you pull back and you stop thinking about like data model and types for a second, just what is the thing that we're trying to ensure? And the main thing that we just care about is round tripping, right? Like we just want to make sure that we can always round trip all of these things between languages. To round trip, you don't actually need a consistent decision about this for all maps or even for all languages. What you need is a very consistent decision for each codec for each language. And the main constraint that you have is that it cannot be mixed types, right? So I'd like kind of at the same place that you ended up, where like you can't mix the key types, but we don't actually need to specify what type the keys are. For instance, if what you do is you decide to encode arbitrary binary into a string key and a CBOR, which is what Filecoin is doing now, that actually round trips in JavaScript just fine, because JavaScript's map only takes strings, but those strings can include invalid characters. So you actually can get a round trip out of that. It's fine. And then if you know that that's what you want to be doing, if what you really want are binary keys, but you're typing them as strings because like whatever, then in your codec you can say, oh, like I'm in a language that supports binary keys. It's always a binary key for maps. Like that's how my codec works. I always do binary keys. Cool. And those actually round trip the same data between those two languages, right? Because nobody is mutating it and it's all fine. You're just changing the decision that you made in a specific codec in a specific language. So I actually don't think that the data model has to define what the consistent type is for keys. I think it actually can leave it up to the languages and the codecs to decide. It just has to be consistent, and it has to be one. It has to be one type. You can't have mixed types. So that was like an interesting thing. And like, I think a lot of our string constraints tend to point back sometimes to like, well, we're using them in maps for this thing. But I think that we should maybe just decouple that. Like, we don't actually need that to be the case. We can just say that like maps have one key type and figure it out for that codec and that language. And like, maybe our decision in Steg Cbor, which makes total sense given the history and what people are already doing, is that it needs to be string typed, but it can just be arbitrary data and it doesn't have to be UTF-8, which is like what we actually have to support now. And then in some languages, or even like, you know, in literally in that library in Filecoin, they're just treating them as bytes, right? I don't know. What do you think? How does that fit with like your picture of this, Eric?
Roughly congruently, but I think the fewer things that you try to promise, the more useless our specs become. Like, I want somebody to look at our specs for this and know what they should do when they write a new library in a new language.
Well, yeah. So yeah. So the DEG Cbor spec should be very specific about how you encode this. What I'm saying is that the data model needs to set some constraints for the codec spec to say what to do, right? And then when you go to implement that spec in your language, you're going to make particular decisions about that. Like here's a very good example that comes like to the string value thing, right? If you look at the problem that we have here, it's really that languages do not agree about strings. And like, we can't fix that. like we're not gonna fix that. And so the choice becomes like, do we try to get really heavy-handed and force people to use types that aren't string types to represent strings so that they can support things that other people can do in other languages? Or do we basically say, look, if you do things that aren't UTF-8, you're going to have a really bad time and you're going to see exceptions in some languages because they're going to try to convert this. And in fact, like, no matter what we say in the data model, that is going to be the case. We actually have no ability whatsoever to solve this. Because like, even if all of our codecs that we ship have this FFI type, like it's basically a binary value for strings, the first thing everybody does with them is convert them to a string. And if it has invalid UTF-8 characters in it, it's going to throw an exception. So all we've done is move the error from the codec to like the thing that people will do with the data right when they first get it. It's not actually solving anybody's problem. It's just like making us feel like we made it consistent. But
so what you're saying is,
yeah,
strings should caps lock
yes,
the
yes,
UTF-8.
Yeah. No, I was like almost jumping up and down when you said like caps lock should.
Like,
yeah. On UTF-8,
we should actually start using that kind of language for some of this stuff.
Yes. Like that is 100% the right thing to have in spec. Where I think that we like can't really, we really don't have the ability to dictate is the must support section. And a good example of this, right, is JSON is not a binary. If we don't want to use the word
must, then I think we're going to have to define levels of compatibility or something and have at least A+ grade and a like B grade compatibility, because it is already the case that a bunch of stuff relies on these string domains, including arbitrary bytes. And so libraries that don't support that are going to have B grade compatibility at best, because they're going to fail to work with major products that already exist on these specifications.
Yeah, but like often
it's
when you
like,
have
it's just like a point. It's still not true. Anyway, I just want to mention it's not true in case of Filecoin. Like Filecoin is not using binary keys in normal maps. It's just like in Cbor. Like they are not using Cbor binary because they don't use Cbor binary. Like in Cbor maps, there are no arbitrary binary data. I just want to emphasize this.
But they are encoding invalid UTF-8,
which have non-UTF-8 bytes. I just checked this with Aaron yesterday, and he said yes, there are strings with non-UTF-8 bytes. Like
if you decode them in Rust, it'll fail.
Then please share it with me, like, because I try to like I basically worked a bit with Will and try to find those. So please share it with me. Okay, cool.
I mean, it may be kind of hard to find one that happens to be invalid UTF-8. Like there may be a lot.
Well, I think what it was is what we found is that it all is Cbor encoded at the most basic level, as expected. Yeah. And so the problem is hands, which they're stored in Cbor as values, not as map keys. They become map keys of the realized hammed. So it's those bytes that are in the value segments of the actual encoded Cbor that are where there's binary data that's not going to be valid.
Yeah, but now you're in ADL land and things change a bit. Like they're not going to be enforced by the codec in the same way. But to come back to it, like sort of try to unwind this again. you often pair a should with a may, not a should with a must. So I think that like the thing that the spec should probably say is you should encode strings with UTF-8. You may encode arbitrary data into those strings, but you should know that that is going to cause you some problems in languages that do not support that. Like that is the consequence of doing that. Saying that like you must support it means that it would force a compromise in some languages that I don't think that we're willing to do, which is to say that all of the strings now use non-native types, or yeah, I mean, even the FFI type in Rust is like effectively a non-native type, or you're using like some kind of like tagged binary type or something. Like you're going to end up doing something special to them that's not a regular string, in order, and like that's just not going to make the codec very usable. And at the end of the day, we don't really control this. Like, it is not that hard for somebody to just then write a codec that decodes them all as strings and just throws when they're not, and just use that instead. And in fact, like often people will just do this, right? Like, and it's the flip side as well. We can't say must be UTF-8 because we know that people aren't going to do that validation, and that they're going to encode stuff into strings sometimes that aren't valid UTF-8 characters. And like, you should be aware that that's a thing that people do. And if you really need it to be UTF-8, you're going to have to validate it. Like there's no getting around it, right? So I think like that's probably where the language needs to be. And then when we look at specific codecs in specific languages, we can get much stricter about this, right? Like we can say specifically in CBOR, like these must be strings, like they might have arbitrary data in them, but they need to be typed as strings for the map key values, right? Like we can get like, we can even say in some codecs, like, you know what, you actually can only do UTF-8 for strings in this codec. And here's like how you do that cleanup or that translation for this codec for whatever reason. And in fact, like this sort of happens already in JSON, because JSON is not a binary format, it's a string format. So like the final outputted entire thing has to be a valid UTF-8 string. And so if you try to just shove certain arbitrary bytes into the string values, it'll like actually mess up the encode. So you like have to do weird escaping sometimes. So yeah, like this is just something that like there are some of these decisions that we have to leave to specific codecs and languages, and yeah, and just warn people like you probably don't want to do this. I mean, the same thing, like we have to warn people about inline CIDs too, and just say like, you know what, like this is a thing that's possible, but like you're going to have a bad time sometimes because there aren't always agreements about what the representation should be. Yeah, I mean, I agree that the spec should be maximally useful, but also like the actual implementation seems to be maximally useful. And here we're like hitting like something of a conflict a little bit. But I think the language that you came up with works if we just replace that the must with a may for the support arbitrary stuff.
Okay. I think we should go to the agenda item first, and then because like we could probably discuss this one like for another 3 hours as we did on Friday. So is it okay if we go on with the agenda item first and then? Okay, cool. It's just for the ticket. I also like I would want to discuss this, but I also try to keep still. Yeah. Okay, so it's so it's
the agenda item is the same topic.
Kind of, yes, but like what's the actual But I handed over to Rod for this one because you have
look, this is the same topic, but it's the chain safe, is that him? The people that are doing the Rust implementation of Filecoin opened this issue, and they're having trouble with the abuse of map keys. And it looks like they're using the standard Serde implementation, and it's just balking on the arbitrary bytes converted to strings that they're doing in Go. And Peter pointed out that this is because they're serializing the label, which contains arbitrary things. So it's like the user can even control what goes in this, I think. So it's the YOLO kind of deal.
It's actually only the user that controls, literally.
Right. So it's I don't know, like, I was talking to Alex yesterday about a whole bunch of stuff to do with spec actors and how they are doing and they're planning to do regular upgrades. And he showed me some of the migration stuff, which has been a bit of a black box for me. And so there is scope for us to propose some changes in some of these things. And it's not that we can rewrite history, because the history is sort of stark, but we can have points in time where the history gets rewritten for a point onwards, and they're going to be doing that regularly anyway. So there's a couple of things here. One is we have scope to speak to this space, to Filecoin, and say, here's a better way to do it. Like maybe we say, you should be using UTF-8 clean 8. That's just a hypothetical. That maybe there's a way you should be doing this that is going to be more stable across implementations, because this is kind of rough. Like, yeah, for all the reasons we've talked about. Just saying, like, it's what the Filecoin implementation has done in multiple places is said, well, the IPLD people said we can't have anything but string keys, so we'll just put everything in bytes and stringify them. And with the Go string of bytes implementation, okay, it's just not very friendly to others. So we could suggest changes here. But the other thing is, I think and that's actually what the Rust implementation people are suggesting, that they'd like this changed. But I also, because we were called into this, do we have any feedback on this? Do we have to say, because I think the Rust people are going to have to live with it anyway, because this is already on chain, so you're going to have to deal with this portion of history anyway. But is there anything that we can suggest that makes this better for them? Like, Volker, are you going to be able to offer anything better in terms of, at some point in the future, in terms of codecs that can handle this? Or, yeah.
Is this label? I think like someone proposed that we just that it could be changed from string to bytes. So if that's an option.
No. So what do you mean by that, though? Because we can't change the encoded value, but you can change the representation. So if you just want to make it so that the Rust maps for DAG-CBOR use byte keys, and then they serialize as basically bytes that are tagged as a string.
I think is the label also about keys, or is it like?
No, label is about a value right now.
Yes, it's a value. Yes, so basically, it's talking about a value. So it's not about keys. So it's really about a value. So yeah.
So there's two things. Right, there's HAMPs and the ADLs, which are CBOR encoded correctly, in that they're a weird map thing that has tuple values, and the values are bytes, and then you're supposed to interpret them as a map that has these bytes as the keys that are maybe going through a string conversion. But the CBOR representation is all good. Then we've got, in markets, they've got a label field that's user specified arbitrary stuff, and they're pushing CBOR byte encoding into that string field. And so that's the invalid place, I guess. Is that right?
What is that used for? Why is the label there?
I think this is that field that was JSON originally, wasn't it?
Yeah, that's the thing that started as CBOR, then became JSON, then became, but that's not the point. The point is that there are places within the blockchain right now that take arbitrary user input, because the label is just convention, what's in it right now. You can literally write anything in it.
Yeah.
And there are two places. One is two places that I know. One is transactions. Send transactions. In send transactions, it is bytes. So you can literally write whatever you want into a round trip. The label, which you also can write whatever you want, is unfortunately a string. And that's where the entire friction comes from.
Why did they do that?
There's a whole
this
document
actually
about
seems pretty clear cut. This seems like that should be the bytes.
Yeah, just change it to bytes.
Yes, but
it sounds like they're trying. Yeah, maybe this is out of scope for us because it's not IPLD, it's not DAG-CBOR, it's just CBOR. And maybe
it's just regular CBOR.
I'm actually not sure. I think it's DAG-CBOR. I'm not sure myself now.
I think
it has to be DAG-CBOR.
Yeah, so to be basically, I think the current problem is like if you would change it to bytes now, and you use the automated code gen or serializers that like the default one that they currently have in the Rust implementation. The problem is that currently it sounds like in the XCBOR, this thing has the tag string, but arbitrary bytes. And if you change it to bytes in a higher level, this becomes bytes and arbitrary bytes. But of course, like as a blockchain, you need to still deal with the old ones where it still says strings and the bytes.
Yeah. So the real problem here is literally they're stepping on the spec change that we literally were just talking about, which is like they encoded thing into a string that is not valid UTF-8, and now they're in a language that it needs valid UTF-8, and so they're getting an error.
Yes.
Like that's the literal problem. Okay.
Yes.
So okay, so what they need to figure out is how they are going to figure out exactly when they're encoding these particular blocks and how they're going to somehow tell the decoder to encode that as a byte value instead.
This is what they currently do. This is what they currently do. So they basically forked. So in Rust, they forked Serde to do this stuff. So they basically they can't use the default Rust serializers anymore because.
I mean, that's what happens when you encode invalid string data into strings. Like you break certain languages. Like this is like the expected behavior. I don't know why they think that like this is something that somebody else fixes.
You break certain libraries, I would say. Like Serde could also have chosen to use FFI strings here, and I think that they probably would.
Well, but that's unreasonable. Like, I mean, like they have a string type, they're going to use it for strings. Like that's like what everybody does. Like that's pretty much. It might be like a Serde problem in that there should be an easier way for you to say, hey, don't encode this is that in Serde. Like that may be a problem.
I think there is. I think that like this was just basically the quick fix, I guess, just to make it work, because that's the whole point. But I think but still like it's there. So it's actually there. I think that's the problem back there. That strings are If it would be all valid UTF-8, everything would be fine.
Yeah. So I mean, like they should just use bytes. I mean, I don't know why they didn't originally. Like that would be a much better idea. Given that there is data on chain, they're just going to have like a codec that knows to deal with this.
Although, I mean, maybe our feedback is simply you should just change your spec to say this is bytes, and then they're not like even historical data works. It just means that they have to interpret. Like the Go people will say, well, this can be a string in some place. Like I don't. Maybe there's a reason. Maybe this is something we actually punt over to Hannah, because this is really
actually all the historical data so far is either binary CBOR, already encoded CBOR, or ASCII, so it won't break anything.
Yeah, okay. Maybe that's our feedback then. Like this is mistakenly labeled as a string just because it's so easy in Go to do string and byte conversions, but it should just be bytes. Okay, maybe that's our feedback.
Hold on, but like I do want to just say that like Eric, you are probably going to end up needing a feature then where somebody can apply a schema that says this is bytes, and I don't care if it says that it's a string in the data model, you decode it as bytes so that they get a consistent value even after they do this. Well, I mean, that literally is a migration, right? Like,
Well, I mean,
one that matches
wait, hold on. So like, for migrations, I know that you have like a whole kind of plan about how migrations work, but like in a migration, you reinterpret old data in the new format, right? You don't have to like rewrite the data because we have no ability to rewrite the data. It's a blockchain. Like,
yeah, sure. So you write two schemas, and you just match whichever one matches, and you're like, okay, that's what it is.
But you can't do that. Like again, the thing with the matching, like I linked something like 5 minutes ago. This is how upgrades work. We had this large discussion like back in July, like how the signaling will work. The signaling is chain height, literally. Like you have exact heights.
Okay, well, that's
to switch your schemas and stuff like that. So my point is that you will need to supply the schemas as it goes through the chain.
This change, you could actually just look at the data and say like which typing tag does it have, and if it has the string tag, then you know which schema that you're talking about. Like we don't have to look at.
You mean we need the CBOR, the tagging? Okay,
yeah.
So
we're just running
could describe this migration in IPLD schemas with nothing Filecoin specific, and we are confident of that. I'm sure Filecoin also has some migration mechanism, and I know nothing about it, but I'm going to assume that it is fine, and I do not care. That is an acceptable amount of knowledge for me to have. We seem that we all agree in this scenario, this particular issue 1248, that there is this field that is currently specified as if it is a string and it contains non-UTF-8 bytes. And we think that that is silly and it should just be a bytes field because that is clearly behaviorally what it is. Fine, solid, super easy. We are additionally, the only thing here that should be running on is we might, as a team, look at this as a potential learning experience for what happens when, rather than if, people do put non-UTF-8 bytes in serial strings, and then other people have to deal with the result, right? That's the one thing that's interesting.
One of the libraries built on top of the thing that you, Eric, are writing will need to be able to read this part of the chain where the seaboard is mistyped. How do you do that?
Yeah, that's what the schema migration stuff is. You end up with two schemas for both versions.
We have serialized data that exists, and in CBOR, it is tagged as saying, I am a string, and it contains these non-UTF-8 bytes. What are you going to do as an implementer? What are you going to do at the end of the day? And so
that's the question. That's the question I have to answer.
This is why I advocate for your library should frickin' deal with it and know what bytes are and like just don't goof around with it, because that's the only definition I can see on a day like this with a problem like this that causes my implementation to work.
I mean, what you probably want to do in a language like Rust where this is a problem is attempts to deserialize the string, and if it fails because of invalid characters, then you basically check if you're in like a strict mode or not. And if you're not in a strict mode, if you're in a like just convert it mode, then you just change it to a byte value. That's gonna like suck, but it's like the only way to get past this without having like super explicit code that says like this property always decoded as a byte value, which is what they're doing now.
I think while in Rust this will work, in Go it will actually throw some of the invalid data away. Silently,
no, I think
right?
Go will just like, Go will just accept invalid data in the string.
But won't it replace it with this Unicode thing? Okay, it will keep it correctly. Okay,
that's the only place.
That's not what you guys said last time. Okay, awesome.
Yeah. The Go has a couple. It has some library features that have that kind of. I'm not a big fan of it behavior about the Unicode error byte, but it shows up in like JSON libraries and some string pretty printers and stuff. But it's in relatively high level libraries that we can just choose not to use, and it's fine.
So what's the action item there? Rod, will you reply on the issue, perhaps?
Sorry, I'll go back and I'll just say, look, this is one of those unfortunate things of language implementations, and the Rust people are just going to have to deal with the historical data at least. But our suggestion is that this field should be changed to bytes for in a future upgrade, so that it's encoded as a byte string, and then it's easy for everyone. Because let's just admit this thing is arbitrary, literally arbitrary. It says it in the spec, so make it arbitrary. And stop dealing with strings, and that's the best we can do. But unfortunately, I mean, and I'm sure the Rust people already know they're going to have to deal with this data anyway. So it's like we've got to deal with the historical craft. So yeah, but let's make it better in the future, and then maybe I'll pull Hannah into that, because I don't know if Hannah wants more things to deal with, but that's kind of in Hannah's basket.
Okay, thanks. I think that's so we have done this agenda item. Yeah, next agenda item is Chris. Chris's.
Hey, yeah, just a quick question. Did we ever, like, what's the current thinking about having like a B tree ADL? That means.
Sorry, what was that?
A B
Go
tree
for it.
ADL?
I don't think anyone needs the permission of anyone in this call to be whitelisted to make a new ADL. The dream is that this should be like a plugin point in general. So like, you want to do it? Do it.
I actually today got approval to contract somebody to do this. So we're talking, Rod and I are talking to somebody right now. But like that wasn't even ready to really talk about. Yeah. We're probably it'll probably be a red-black tree.
Well, yeah, something that allows you to do like non-exact lookups. We have HAMPed for exact match lookups. But if you want to do range or something like that, then you need a B-tree. So yeah, so I was just wondering, I mean, since we didn't have one, I didn't see anything in the specs. I'm wondering if we talked about it and we're like, no, that we're never going to do that for some reason, but it just sounds like no one's had the need. So that's good news. Yeah, it's even better news that somebody actually build it.
Yeah, no, I mean, Rod did a lot of exploration when he first started around this, and we have a bunch of sort of different sorted collections that we want to look at. The reason why they haven't been done so far is that so much of the work has been going into Filecoin, and these data structures are not going to be hash consistent, right? Like unless you can guarantee that you're always going to do a rebalance, then they're not going to have the same hash as somebody else with the same data, because insertion order really is going to change the structure. And so they're not useful for blockchain. They're not useful for like some different content addressing use cases, but they're really important for databases and other stuff like that. Like I really want it for DagDB because for secondary indexing, I don't need a consistent hash, but because you don't actually share that between parties. Like I only need that for the primary store, so it's fine. But yeah, we're finally now getting around to that. But yeah, and then once we have some good patterns there and some good stuff, then like I want Volker to write an archery. Volker needs to write an archery. Okay.
What's an archery?
Geospatial indexing.
I would also mention somebody else who's not on the call right now, but might be good to talk with is Ian from the Pyrgos project. I know at some point they've used other, I think closer to B+ tree structures like this, and then they moved over to HAMPs and CHAMPs. But he might have some interesting observations about that. I think they were driven a lot by the content addressing convergence story, but they did ship with a bunch of other tree structures for a while, so there might be learning experiences there.
Yeah, definitely. That's great.
He lurks in, I think he lurks in our IRC pretty reliably too, if email can't be found. I don't know, whatever.
I do have a hunch that there is a form, there's at least one form that we could implement that does have something approaching canonical structure. It's just going to be a very novel implementation of some kind of B or red-black or some other balancing data structure that converges. So, and I think with these data structures, there's going to have to be multiple implementations, each with different trade-offs. And that's the right way to go because different users need different trade-offs. So some users won't care about convergence. They just want efficiency. Some users won't care about block size. And so like a binary tree might be fine. But in some users will care about block size. So, and mutations come into the question. So I think it's right that there should be multiple implementations of this. So if you have ideas, you definitely should be experimenting with them because it'd be really interesting to see what shakes out of that process and then figure out what the edges of those trade-offs are.
Yeah, I think that we sometimes mistakenly think that like IPLD is at the level of the database for like the analogous kind of centralized model. But it's actually at like the level of like the disk, right? And so it's not like we're going to have a database or a way to do this. It's like there are many databases because they all have very different performance profiles, and that the way that they implement those performance differences is primarily how they write those things to disk and how they do transactional architectures between each other. And so like we're going to end up with many different trees that functionally do the same thing but have wildly different performance characteristics.
Maybe we're not quite the disks, but we're like the concept of row structuring.
Yeah, I mean, like where you implement the linking in a database is that you literally write like where the other location on disk is, right? And we're like basically at that linking layer, like where you define how those things link together. So it is somewhat analogous.
I also think it would be cool to maybe research something like a Patricia tree structure, because it seems to me like you could make some hybrid of Patricia /B plus tree, and you could probably get somewhere that was both sorted and reasonably efficient and reasonably convergence friendly.
What's interesting is like, I think that we're a little bit here underestimating how much work we can do above the primitive ADL layer. Because like, if you look at like DagDB, for instance, so you have the hash of the database between different states, and then you can always do a diff of the primary store between those states. So that means that as long as you're pairing each of those next to an index, then for any state, you can always only apply the diff over them. And so you actually get like really interesting and better kind of batch performance characteristics out of just like putting a hemp next to a red-black tree, just the roots. Like already you have like really nice kind of performance characteristics between them, and you're getting over a lot of the problems that you would have. So, and I wonder like how far you can stretch that, right? Like how hybrid can we get with like where we shove some of these different data structures together to get different characteristics? It's a cool problem space. Like I want to like stop managing maybe and just like play around with this, but this would be my jam if I just got to write code.
We have 5 more minutes to go. Any other stuff people might want to talk about?
So I just put a link in. I've been working with CDDL quite a bit, and so you might want to take a look at that for writing the entire spec. And I've been doing some branching logic for my work, and it did work. So testing the validity in CDDL and branching if the based on the type. And it was just this Rust library was just updated yesterday. I think it does support now both validating CBOR as well as JSON.
Cool. Anything else? Nope. Then, then I close the meeting and see everyone next week again. Goodbye.
Bye, everyone.
Hang on, sorry. There was this HAMP thing. Were we going to talk about the HAMP?
Oh, please do.
Okay, so the problem we have right now is that the changes we merged last week have a conflict in the kind union. So I went with a tuple representation for the nodes. I think I've been infected by the Filecoin need to make everything compact and small. And there's the link, yes. And so, but then when you go to this recursive point where you could have buckets or links to child nodes, it's a kind union, and the bucket itself is a list, and the hash map node that we've still listed as a map. So that's wrong. It seems to me the easiest answer is to remove the representation tuple there, and then just have them as maps. And the objection to that is simply that you're wasting space by having the map keys in there in your encoding. Maybe we shorten them, or maybe we don't worry about that. I think that's the main path forward here. The obvious path forward is to just turn it back into a map. Anyone have any thoughts? There's two fields in the map. One is map and one is data. There's a map is a byte as bytes, and the data is an array. So no, yeah. Okay, fine.
Bring it back into a map sounds right. I would call them bit field, rename B, and data, rename D, personally. I also think the name map for that field is really, it confused me. It's a bit field, right?
I would say it's a bit map.
Well, okay, fine. It still shortens to B.
It's a mapping. Okay, do you think we should use a rename in there, or should we just make the names short?
I would use a rename for that. That's what they're for.
Okay. So maybe, okay, bitmap or bitfield and rename it to B, and the data, what were you saying that? I'll just rename data to D. Yeah. Okay, I'll do that now. That's it then.
All right. Again, is there anything else? We still have 1 minute. No, it doesn't seem like it. Then goodbye, everyone, and see you all next week. Bye.